excuse me because I've still got a cold. I've been thinking about orbital trajectories and how to get in and out of orbit since I was a kid. It's just one of those things that I think about on a regular basis. And when I was watching the X Prize, the first X Prize, where Burt Rutan won it with Spaceship One, it became apparent that he has something called a feather. It isn't that this feather is miraculous or something. The actual miraculous thing about it is that he shoots himself up into suborbital space, and then at the apogee of his rise, the spaceship comes to a stop, complete standstill, and it may be moving at 200 or 300 miles an hour in relation to the planet's surface. It may be 500 miles an hour, but it certainly isn't 17,000 miles an hour or 15,000 miles an hour. It's a couple of hundred miles an hour maximum, because he's been using all of his thrust to go straight up, because it's got such tight tolerances. He needs to get up into space, because he wants to win the X Prize. He needs to get to 400 and something thousand feet or something, 100 kilometres, 62 miles, whatever it was he needed to get to. So he shoots up there, and then as it comes back down again, instead of using retro rockets and what have you, he folds the wings back, and that acts like a shuttlecock and it straightens the ship up. And it's nothing special about it. That just orients the ship so it comes back into the atmosphere in the correct manner. Now, at 60 odd miles, you're not going to gain too much speed on the way back in. At 100 miles, you're not going to gain too much speed on the way back in again, unless of course you're going to use Earth's gravity plus 15,000 miles an hour or 20,000 miles an hour, whatever the space shuttle comes in at, if you see what I'm saying. Now, the space shuttle needs a heat shield, because it goes up, it's travelling around at whatever it is, 17,000, 20,000 miles an hour, and then when it wants to come back to Earth, it does deal with burn. So what I'm trying to say is, I don't know if we can see this here, yeah. So you got the oh, it's all backwards, all the text is backwards. That's really drastically bad, that is. But you can see at the top is orbiting nicely. Then they do an orbital manoeuvre and a deorbit burn, and they decrease from 17,000 miles an hour to 15,000 miles an hour. The space shuttle does another manoeuvre. It's a bit dumb. It comes around and it starts creating plasma. See the plasma up here coming off the heat shield of a normal cone, like the Soyuz capsule coming back in, and this is like the space shuttle coming back in. And the heat shield, the black bit's the heat shield, yeah. But it needs the heat shield because it's doing 15,000 miles per hour. Now, as we know, with our supersonic jet fighter programs in England, Canada, America, Russia, to do Mach 1, the speed of sound, you need a certain shape of aeroplane. Otherwise you're just wasting a lot of fuel and energy to get past the speed of sound. And then to go past two times the speed of sound, you need a better shape and more thrust. And then when you get up to Mach 3 and Mach 4, then you're starting to use special metals, because the friction of the air going past in the dense atmosphere heats the fuselage up, basically. So you can use composites or special materials like the SR-71 Blackbird plane. Its fuel tanks leak on the runway when it takes off, but as soon as it gets up to Mach 2, Mach 3, it heats up and all the fuel tanks seal up and whatever you like. Heat because of friction, because you're going through the air, is what I'm trying to say. But when you're doing 17,000 or 20,000 miles an hour in space, because you're trying to get to the International Space Station, which is 250 miles up. Well, at 250 miles up, if you could burn your engines long enough to come to a complete standstill in relation to the Earth's surface, and then just drop straight back into the Earth's atmosphere, you've only got to travel 250 miles for a start. The second thing is there's something called terminal velocity, and once you start hitting the Earth's atmosphere, you won't go any faster than that. There's no way that you can go any faster than that. It's a proven fact. It doesn't matter whether you're a feather, a golf ball or a car. It doesn't matter what you are. If you drop from a height, you'll get to a certain speed, and that will be it. Go and watch Top Gear. Go and watch Richard Hammond drop a Volkswagen Beetle from a mile high and then race it with a Porsche in a desert. If you dropped it from 3 miles high, it wouldn't have gone no faster. Terminal velocity is terminal velocity. And at terminal velocity, even a Volkswagen Beetle and the glass in its windows stays intact. It's miraculous. It really is miraculous. But if you take the Volkswagen Beetle up into space and shoot it round at 20,000 miles an hour, then do a de-orbit burn, and then let that go through the atmosphere at that speed, I think it's probably going to disintegrate into a ball of plasma fire. But if you stop it to 0 kph in relation to the Earth's atmosphere and drop it in, it ain't going to fare too well. It's going to, go past the terminal velocity for a start, but when it starts in the atmosphere, it's going to slow down. And because it's only going to get to arc around about 1,000, maybe 2,000 miles an hour maximum, you're not going to have too much of a heat shield on the Beetle to make it survive. So I can understand, within those reasons what I've just said, it's probably why they're holding back technology from you. Because there's no doubt in my mind that I could fire a rocket into space, orbit it a few times, send it around the moon, do some dangly stuff, bring it back into Earth's orbit, then do my de-orbit burn to 0 mph and bring it into Earth's atmosphere without a heat shield. I'll put money on it. Give me the money to build the thing. I'll build it, and I'll prove it. And if I prove it, what are you going to do? Are you going to lock me up like the Catholics used to lock up people like Galileo for saying that the Earth isn't at the centre of the universe anymore? What are you going to do? Because what I've just said is the way it is. That's the way it is. There's no other way around it. What I've just said is the way it is. Just skim the atmosphere, do a de-orbit burn as you're skimming the atmosphere, then bring yourself back towards the atmosphere a little bit, and then back to 0 mph in relation to the Earth's surface, and then just float in like that at terminal velocity, and then fly it down because you're a winged aircraft. But I wouldn't be surprised if I could take something like a Lightning fighter jet and go to space and come back again, if you equipped it properly with heating and stuff like that. You know what I mean? Obviously, you'd have to change one of the engines to be able to breathe in space. But what I'm saying is, what are we messing about at? Why are we not doing the right things? Why are we doing the wrong things and taking so long to do them? It's just a cretin society that I see every day when I go out there. It's just sad. Really, really sad what I see when I go out there. And I don't understand how so many people can be brainwashed so convincingly by so few people at the top. Is it that they're scared? Are you scared of your government? Are you scared to speak out? What is it about you?